Hey everyone, welcome back, and today let's solve LeetCode problem 2894 titled Divisible and Non-divisible Sums Difference. So we're given positive integers n and m, and we have to define two integers as follows, as num1 to be the sum of all integers that are in the range from 1 to n, both inclusive, meaning they both include that range includes both 1 and n of all the integers sum that are not divisible by m. And num2, quite the exact opposite of that, so all the numbers in that same range, but in this case that are indeed divisible by that m input integer. And we have to return the value or the integer resulting in num1 minus num2 once we build both these two integers. So in example 1, we have our two input integers n and m to be 10 and 3 respectively. Effectively, we have to iterate over 1 to 10, both inclusive, and check which numbers have the property of being divisible by m or 3, and which do not, and sum up all the values with those properties accordingly, and return the difference between the two. And in this case, that difference is 19. All the integers in that range from 1 to 10 that are divisible by m, or that are divisible by 3, would be 1, 2, 4, 5, 6, 7, 8, 10, that are not. And all the values that are divisible by 3, which are our num2 values, would just be the multiples of 3 in that range of 3, 6, 9. And so the difference would be 37, the sum of all the integers in that range that are not divisible by m, or our num1 value, minus the num2 value, which is really just all the integers in that range that are divisible by 3. And in this case, that has a result of 37 minus 18, where num1 and num2 are 37 and 18 respectively, and that gives us a final value of 19, which is our output. Applying the same exact logic to examples 2 and 3 here, we have outputs of 15 and negative 15 respectively. At the end of the day, the reason why this is negative is because we have a higher num2 value than num1, meaning there's a higher sum total of integers that are divisible by m versus integers that are not. Why? Because in this case m is 1, and the truth is any integer is divisible by 1, and so this is going to be a large 0 minus a large integer of 15, which would result in negative 15. So for the constraints here, we see that n and m are both going to be between 1 and 1000, which are actually rather small for input constraints, and also for the problem context as well, which brings us to how do we really solve this problem? And the reality is, it is actually a very straightforward implementation. Really, all we have to do is just that singular pass. At the end of the day, we only need one pass to solve this problem, and that is the pass of iterating over all numbers from 1 to n. Because as long as we have that pass, we can check for all the values that have what specific property of being divisible or not being divisible of m, and all we have to do is just sum them up each iteration until we finally build up both of our num1 and num2 values in that same pass once the pass finishes, and at that point it's really just returning the difference between those two values, and we're done, right? So it's a very straightforward simulation problem where we just again iterate over the specific range of values, find or build up our num1 and num2 properties based off of the values and their sums in that range, and then just return the difference exactly what the problem tells us, right? Really, and what I mean by simulation is we're simulating or really just performing operations or doing exactly what the problem statement told us, just in code, right? So let's go ahead and get into that solution. Now, obviously, since we want to build up integers num1 and num2, we have to first initialize them ourselves because these aren't inputs. We build these integers ourselves, and so we're going to first initialize them to both be 0 as our starting values, and we'll build them up from there. Now, let's actually begin the iteration or the single pass from 1 to n inclusive. So for I in the range starting from 1 going up until n. Now, something key to note here in Python is that we actually go up until the exclusive value right before our second parameter in for loops. And so to include n in this pass, I have to actually go up until n plus 1 exclusive or n inclusive to include that n in this range from 1 to n to cover that value in my range that I iterate over as well. Now, I really just have two different cases for every value in this range or every integer in this range, and that is either it's divisible by m or it's not. So if I modded by n is not equal to 0, guess what? That means that I is not divisible by m. There should be m, not n. So if I modded by m is not equal to 0, meaning it doesn't have a remainder of 0, it's not divisible by m, well, guess what? This is a value that we have to sum up to num1, and so we're going to add to num1 the value of the current integer, which would just be I, the current value that we're iterating over. Now, the else conditional for this case is very straightforwardly, if it is divisible by m, meaning it has a remainder of 0, if that's the case, well, then we really just want to increment num2 by 1, because we want to add to num2, or sum up to num2, the values that have as divisible, or rather they are divisible by m, meaning the remainder is 0 rather than not equal to 0, and so we're just adding the current value I in that case to num2, and effectively once that for loop executes, once it terminates, once we've covered all the values between 1 and n, and we've built our num1 and num2 integers accordingly, all we have to do is exactly what the, again, problem statement told us, return the difference between them. More specifically, return the difference between num1 and num2 in that specific order, so we return that value, and we're done. So that's really it for this solution. If we were to submit this, as you can see, it really is just about as efficient as you can get it to be, and it does work. And again, how we're really solving this problem on a high level, really just, again, simulation problem, directly just iterating over all the values that we want to from 1 to n, checking if they're either divisible or not divisible by our input integer m, and incrementing the sum of our num1 or num2 values accordingly, and then finally just returning their difference, right? So for the runtime complexity here, quite straightforwardly, it is linear. It is just really big O of n, because we have a single iteration going up until all the integers from the range from 1 to n, and the memory complexity is actually just going to be constant, or big O of 1. We're not actually using any auxiliary memory or any extra data structures, just a few integers like num1 and num2, but they won't actually take up space linearly with our input, and so it is a constant memory complexity. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel, and without further ado, I will see you guys in my next video. Bye-bye.